Imagine for a second that you've just stepped onto the deck of a multi-million-dollar yacht. The sun is shining, the water is, that perfect shaded glass bottle blue, and you walk up to the helm.
Oh, the best feeling.
Right. And it looks like the cockpit of a futuristic spaceship. There are these massive, gorgeous, glowing touchscreens everywhere.
Just absolute luxury.
Exactly.
Yeah.
So you press a button, expecting the ultimate luxury experience, and, well, nothing happens.
Thanks.
Yeah. The radar freezes, the music cuts out, the Wi-Fi just drops completely. You haven't even untied the lines from the marina yet, and the entire technological nervous system of this boat is crashing.
Which is a nightmare scenario for any owner.
A total nightmare. Welcome to the Deep Dive. Today, we're looking at why putting million-dollar tech on the ocean is just a recipe for disaster.
It really is.
And we're going to see what the incredibly high-stakes world of yacht integration down at West Palm Beach can teach us about, well, designing failure-proof systems.
Because the stakes are incredibly high out there.
They really are. And trust me, the lessons we are pulling from our source material today, they apply whether you are outfitting a super yacht for a global voyage or, I don't know, just trying to manage the complex information systems in your own daily life.
Yeah, the principles are exactly the same.
Okay, let's unpack this. Because when most of us think of a yacht upgrade, you naturally picture buying shiny new screens, right? Like giant speakers, and the fastest internet dish on the market.
Right, the fun stuff.
Exactly, the fun stuff. But our source reveals a completely different reality. The real objective isn't buying gear at all.
No, not even close.
It's preventing these disastrous cascading system failures that only reveal themselves when you are completely isolated, literally miles away from the shore.
Yeah, it's the classic illusion of the user interface.
The illusion. What do you mean by that?
Well, we look at a sleek, edge-to-edge glass display, and we just assume the unseen infrastructure behind it is just as elegant.
Right, because it looks pretty.
Exactly. But the marine environment is arguably one of the most hostile places on Earth for delicate electronics. I mean, buying a top-tier piece of equipment is only a fraction of the battle.
So the gear itself isn't the problem?
Not usually. The real challenge is how that equipment is integrated into a living, breathing, violently moving vessel.
Violently moving. Yeah, that leads to a really terrifying scenario outlined in the material. They call it the dock versus offshore dilemma.
Oh, this is such a common issue.
Right. So you have owners going out and buying the absolute gold standard of premium brands. We are talking like Garmin, Furuno, and Raymarine for navigation.
It's the best of the best.
Yeah. Starlink for satellite internet, Peplink routers, Crestron for the entertainment system.
Top tier stuff.
Top tier. And yet, two different yachts can buy the exact same list of premium gear from the exact same brands and get completely different results.
Literally night and day.
Right. One boat runs flawlessly. The other boat, well, it works perfectly while tied up at the dock, but completely and utterly fails the second it hits the open ocean.
It just crashes.
Yeah. The source lists these recurring symptoms, like equipment conflicts, totally unstable networks, difficult to service equipment racks, and ultimately just horribly expensive rework.
What's fascinating here is that hardware failures from the factory are rarely the actual culprit in those situations.
Barely. Never the hardware.
Barely ever. I mean, when a system crashes 50 miles off the coast, human instinct is to blame the brand, right?
Sure, you'd say, like, this radar is garbage or this router is totally broken.
Exactly. But the failure is almost always an architectural failure. They just fail to anticipate the real-world operating conditions.
Wait, I have to stop you there because I am genuinely confused by that.
Sure.
If I am spending, say, $50,000 on a top-of-the-line radar or the most expensive sonar module on the market, shouldn't it just work out of the box?
You would think so.
Yeah. So what does this all mean for the actual user experience when you're miles out at sea? Why does the environment matter if the hardware is so premium?
Well, think about what happens when you leave the dock. At the marina, you have clean, stable shore power.
Okay, yeah.
The boat is perfectly still. The ambient temperature in the cabin is air-conditioned and beautifully managed.
It's basically a living room.
Exactly. But the minute you drop those lines and fire up those twin 2,000-horsepower diesel engines, everything changes.
Oh, the vibration.
The vibration is wild. It shakes every loose wire crimp, and the voltage drops and spikes constantly. And crucially, there's the heat.
Right, the unventilated equipment racks. The source mentioned that.
Yes. You pack a dozen high-powered processors and amplifiers into a tiny, unventilated cabinet deep in the hull of a boat. In a lab, they run fine.
Because it's cool in a lab.
Right. But offshore, surrounded by hot engines, they experience thermal throttling.
Thermal throttling.
Yeah, the processors literally overheat and shut themselves down to prevent melting.
Oh, wow. So the gear is just trying to save itself.
Exactly. Or consider electromagnetic interference, or EMI.
EMI.
If an installer runs high voltage power lines parallel to your delicate data cables.
Which seems like a basic mistake, but I'm guessing it happens.
It happens all the time. The magnetic field from the power line actually induces an electrical current in the data cable. It flips zeros to ones in the data stream.
Wait, it changes the actual data.
Yes. So suddenly, your autopilot receives corrupted GPS coordinates and the boat aggressively veers off course.
That is terrifying.
The GPS antenna isn't broken. The architecture of the wiring is what failed.
So it's like buying the engine of a Formula One car, but dropping it into the chassis of a golf cart.
That is a perfect analogy.
Right. The engine is undeniably world-class, but the torque immediately twists the frame, and the tires just can't grip the road. The parts are premium, but the underlying system simply cannot handle the power or the environment.
Exactly. Plug and play is a total myth in the marine environment.
A total myth.
Yeah. When you're offshore, your user experience completely depends on how well disparate components have been forced to communicate. If the technician didn't build in maintenance access, a simple loose wire in a cramped closet becomes an unfixable nightmare.
Until you return to port, right?
Yep, you're just stuck.
Which means the only way to actually solve this problem is to address the environment before you order a single piece of hardware.
Before you even open a catalog.
Right. The source calls this the system design phase, or the invisible blueprint.
The blueprint stage is absolutely where the battle is won or lost. I mean, this phase isn't about picking out brands. No. It's a comprehensive architectural drawing of the yacht's technological nervous system. You are mapping out equipment compatibility, power distribution, thermal management.
To stop the melting.
Right, and the physical mounting positions.
And what struck me in the material is that this blueprint has to reflect how the vessel actually operates in the real world.
Oh, totally. Form follows function.
Like a 40-foot weekend cruiser operating in the shallow waters of Palm Beach needs a completely different setup than an offshore sport fishing boat hunting tuna in the deep ocean.
Night and day difference.
You have to match the radar's range to the vessel's speed and size. You have to think about helm ergonomics.
Ergonomics are huge.
Yeah, like where the multifunction displays are physically mounted so the captain can actually reach them.
Yeah.
But I look at the marine industry today, and they heavily advertise these standard prepackaged equipment bundles.
Oh, I know. They're everywhere.
So isn't it overcomplicating things to custom design every single element? Why not just buy the standard weekend cruiser bundle off the shelf and save time?
It seems easier, right?
Yeah.
But it actually saves money to customize because standard packages are a massive trap. They lead to the exact frustrations we just discussed.
Oh, so?
Well, let's say you buy a premium bundle. It comes with a remarkably sophisticated deep water sonar module.
Okay, sounds cool.
It is cool, but if you only use your yacht for cocktail cruises in the intracoastal waterway, you now have an expensive power-draining module that remains completely unused.
Oh, so you're just dragging it around.
Exactly. It takes up physical space in your rack and draws unnecessary voltage.
Or the helm ergonomics.
Yeah.
Like if the standard bundle assumes a dashboard layout that doesn't match your specific boat, your screens might get mounted too low.
Which is a huge problem.
Right. Because at 30 knots, if the captain has to physically look down at their knees to check the radar, you've just created a massive safety hazard.
Precisely. System design maps the technology directly to human behavior.
Human behavior. That makes so much sense.
Yeah, answering fundamental operational questions like who actually drives the boat and how many stations need full control prevents you from having unnecessary equipment duplication.
Or systems competing for bandwidth.
Exactly. And bandwidth is really the core issue today because everything on a modern yacht is connected.
Yes, the network. The source makes it incredibly clear that on a modern vessel, you cannot treat electronics as siloed components anymore.
Not at all.
You change one thing, and the ripple effect hits everything else.
In the past, the radar did radar things, the radio did radio things. Simple. But today, owners expect a floating smart home.
They want it all.
They want onboard internet for remote work, high-definition streaming, smart lighting integration, and continuous remote vessel monitoring.
It's wild.
The network really is the spine of the entire ship.
Here's where it gets really interesting. Because the infrastructure required to support that is just wild.
It is complex.
We're talking Starlink and satellite arrays, backed up by LTE and 5G cellular systems for when you are closer to shore. plus vessel-wide Wi-Fi that actually has to penetrate thick fiberglass bulkheads.
Which is not easy to do.
No, and the source specifically highlights integrated solutions to manage all this, like something called the MDS blender.
Oh, the blender is a game changer.
So normally, if your satellite goes down, your internet drops, and then a few seconds later, it reconnects to the cellular network. It's called failover, right?
Right, standard failover.
But the blender doesn't just failover. It bonds the connections.
Right. Bonding is a crucial mechanism for seamless operation.
Break that down for us. What is bonding?
So instead of waiting for one connection to fail and then switching over, a bonding router actually chops your Zoom video call into tiny data packets.
Okay.
It sends half of those packets over the Starlink satellite in space and the other half over a terrestrial 5G cell tower.
At the same time.
At the exact same time. And then it reassembles them instantly on the other side.
That is incredible.
So if the satellite gets blocked by the ship's mast as it turns, you don't even notice.
Because the 5G is already running.
Yes, the 5G connection is already carrying the load. You never freeze on screen.
Wow. And to manage all that data without crashing the boat, the network has to be segmented.
Highly segmented.
Right. Think of a segmented network on a yacht, like a very high-end restaurant.
Oh, I like this analogy.
So you have the kitchen, right, which represents the captain, the crew, and the critical navigation systems. They need to get their food to the pass without any interruptions.
Crucial operations.
Right. Then you have the dining room, which represents the guests. The guests are out there streaming 4K video, downloading huge files, posting to social media.
Hogging all the bandwidth.
Exactly. And how does a well-designed network practically change the day-to-day experience for the people on board?
Well, in network terms, you separate them using what are called VLANs, or virtual local area networks.
Exactly. It's like building two completely separate sets of hallways behind the walls of the restaurant.
That's exactly what it is.
So no matter how chaotic the dining room gets, no matter how much bandwidth the guests are consuming, the chef in the kitchen has a dedicated, completely unobstructed hallway to communicate safely.
The navigation systems never lag.
Right. If the dining room gets too loud, it cannot be allowed to slow down the kitchen's critical software updates or weather downloads.
And we should point out, this isn't just about bandwidth either. It's heavily about cybersecurity.
Oh, true.
Yachts are high net worth targets. If you don't segment the network, a hacker who manages to compromise the guest Wi-Fi, say, through a vulnerability in a smart TV in a guest cabin.
Right.
They could theoretically pivot over to the vessel's control systems. The dedicated hallways you mentioned physically isolate the navigation data from the public internet traffic.
Which is honestly a lesson we can all use at home.
Oh, absolutely.
You really should have your cheap smart home light bulbs and your smart fridge on a completely separate Wi-Fi network from the laptop you use to log into your bank account.
Yeah, you don't want a compromised refrigerator exposing your tax return.
Definitely not. But returning to the boat, what is the ultimate payoff for all this complex networking?
If we connect this to the bigger picture, the ultimate real-world value of a properly designed segmented network is operational invisibility.
Operational invisibility. I love that term.
It's the holy grail. It means the technology completely absorbs the complexity of the environment so the user never has to think about it.
It just fades into the background.
Exactly. The ultimate luxury isn't having a massive touchscreen. The ultimate luxury is a system that just works.
Yeah.
It means when you move from the remote waters of the Bahamas back to a crowded marina in Florida, the system handles the handoffs invisibly.
No manual switching.
None. And crucially, it allows for deep remote troubleshooting.
Oh, tell me about that.
Well, if you are anchored in the Exumas and an engine sensor throws an error code, a well-designed network allows a technician back in Palm Beach to log in securely.
From another country?
From 1,000 miles away. They look at the data packets and potentially fix a software glitch remotely. It saves you a massive emergency tow bill.
Wow. But building a network with that level of resilience where satellite, cellular, and marina Wi-Fi all bond seamlessly while preventing cyber attacks, that requires a level of IT expertise that goes way beyond traditional boat repair.
Way beyond.
Which brings us to the final piece of the puzzle, choosing the architect. Because if you need an invisible blueprint and a segmented IT ecosystem, the person executing your project cannot just be a salesperson looking to move boxes.
No, absolutely not.
The source draws a massive line in the sand between a product reseller and a systems integrator.
It's a vital distinction.
Yeah.
I mean, a product reseller is motivated by hardware margins.
They just want to sell you parts.
Right. But a systems integrator wants to engineer a life cycle solution. The guide points out several key indicators of a true integrator.
Like what?
First, they actually do the system design review before anything is ordered. They give you schematics, not just a price quote.
That makes sense.
Second, they utilize technicians who hold specific NMEA certifications.
NMEA, that's the National Marine Electronics Association, right?
Yes, exactly.
What exactly does a certified technician know that, say, a really smart computer guy from a big box store doesn't? Like, why does it matter?
They understand marine physics and chemistry.
Chemistry?
Yeah. For example, an NMEA certified tech knows you can never use standard copper wiring on a boat.
Because of the salt.
Exactly.
Right.
Standard copper wicks moisture from the salt air and turns green with galvanic corrosion within months.
Oh, it just rots.
It literally disintegrates from the inside out. You have to use specialized tinned copper wire to prevent that. A standard computer technician wouldn't know that, and their installation would just rot behind the walls.
Wow. Okay, that makes total sense. And looking at the source, they actually provide a case study of what a true integrator looks like.
Yes, the guide highlights a company operating out of Palm Beach called Concord Marine Electronics.
Right.
They've been in the marine tech space since 1988.
Which, in technology years, is basically the Jurassic period. Surviving that long in tech is unheard of.
Absolutely unheard of. But it's their operational structure that makes them a strong example. They have direct partnerships with the manufacturers, which streamlines warranty claims.
So you're not fighting with customer service.
Right, and they boast over 185 star reviews and offer 24/7 support plans.
Which is huge.
It tells you they aren't just doing the installation and vanishing. They are committing to long-term commissioning, rigorous sea trial testing, and ongoing maintenance.
But I want to look at the psychology of the buyer here for a second.
Okay.
Because the source emphasizes looking at the life cycle value rather than just the initial quote. But human nature is to go with the lowest bid.
Of course it is.
We like paying for shiny screens we can touch. We hate paying for invisible things like design time or wire management. So if I'm an owner, what is the actual tangible financial danger of choosing the cheapest installer for a project like this?
The danger is that in complex systems, the least expensive installation almost always becomes the most expensive one.
How so?
Well, how does the lowest bidder save you 20% up front? They skip the blueprint phase. They use the cheaper non-marine grade wiring we just talked about.
Right, the stuff that rots.
Exactly.
Yeah.
They cram all the equipment into an unventilated rack without labeling a single cable or providing any network documentation.
Oh, a rat's nest.
A total rat's nest. So a year later, a single display monitor goes bad. Because there is no documentation and the rack is a tangled mess, the next technician has to spend 40 billable hours just tearing apart the entire system to trace one wire.
40 hours.
Yeah, so a $500 screen replacement turns into a $5,000 labor bill.
It's exactly like hiring an unlicensed, incredibly cheap contractor to renovate a bathroom in your house.
Yes, perfect comparison.
You feel great because you saved $2,000 on the initial bid, but they didn't waterproof the shower pan correctly.
And then the mold starts.
Right. A year later, water is leaking through your living room ceiling, and you have to rip the entire bathroom down to the studs and pay to build it twice.
Exactly.
It's a classic case of buy once, cry once. If you try to cut corners on the nervous system, you pay for it exponentially down the line.
You really do.
To quickly summarize the journey we've taken today, we started by moving past the allure of shiny brands. We learned that buying a world-class radar doesn't matter if you drop it into a fundamentally flawed environment that causes thermal throttling or electromagnetic interference.
Right, the F1 engine in a golf cart.
Exactly. We explored the absolute necessity of the invisible blueprint, taking the time to map the technology to actual human behavior before running a single wire.
Crucial step.
We dove into the complex reality of marine networking, where bonded connections and segmented VLANs act as the central nervous system, keeping the kitchen safely separated from the dining room to achieve that ultimate goal of operational invisibility.
Which is what everyone actually wants.
Right. And finally, we saw why finding a true integration partner, someone who understands tin copper wiring and long-term support, is the only way to protect your investment.
It's the only way.
And for you listening, even if you never plan to set foot on a yacht, understanding this difference, the difference between just buying a bunch of disparate parts and carefully architecting a cohesive system is a masterclass in managing any complex project in your life or business.
It really is. And this raises an important question.
Oh.
As we look at the trajectory of these installations, everything is moving toward flawless, invisible integration.
Right.
These vessels are becoming completely reliant on continuous, high-speed, bonded internet for remote diagnostics, weather routing, and 4K entertainment. But if a yacht is now just a highly complex, perfectly connected floating node on a global IT network, what happens to the romantic concept of truly disconnecting at sea?
Oh, wow.
If you can never really be out of reach, has the fundamental nature of getting away from it all offshore changed forever?
That is a fascinating thought to leave on. I mean, the ultimate luxury used to be complete isolation, and now the ultimate luxury is never dropping a Zoom call while anchored in the middle of the ocean.
Times have changed.
They really have. Thank you so much for joining us on this deep dive into the hidden world of marine electronics. Next time you see a picture of a gorgeous helm station with all those glowing touchscreens, you'll know exactly how much invisible architecture it takes just to keep the lights on when the marina fades into the distance. We'll catch you on